Hello all, let's start chapter 4, the first section in chapter 4. We are covering 4.2 and chapter 4 is about probability or probabilities. Uh, First, I will not give you a definition for probability. I'll wait like few seconds, maybe few minutes, then I'll put a definition for probability for you. The first thing that I want to do here, like the day that we start the statistics class, the first day I gave you some definitions, some vocabularies that you need to know to deal with this book. I do the same way here in this section. I'll start with some vocabularies that you need to know for chapter 4, correct? The first one is event. What is an event? Correct? The translation of event in chapter 4 or in the context of probability is a little bit different than we translate in our daily life. Even for us in daily life is a function, like when something is going on, a party, right? We translate that one as an event. But here, event has a special meaning or a special definition for us in probabilities. Event means a collection of outcomes of a procedure. A collection of outcomes of a procedure, we call it what? An event. How? Let me explain. For example, when you flip a coin, correct? For example, a quarter, you want to flip it, correct? When you flip a coin, this becomes your procedure. Flipping a coin is your procedure, correct? The outcomes, when you flip, you can get a head or a tail, correct? There are two outcomes, head or tails, correct? Now, this is your outcome. When you flip a coin, this becomes your what? Outcome. All together, this procedure and the collection of these outcomes, collection means, for example, if you flip a coin 3 times, correct? You flip one time, for example, you get a head. You flip next time, you get again a head, correct? And you flip for the third time, maybe you get a tail, or maybe again head, who knows, correct? When you collect this information, the collecting of this information or this procedure, we call it what? An event. Hopefully it will be clear for you what does it mean an event in the context of probabilities, correct? Now we learned what is event. It's time to know what is simple event. A single outcome. a single outcome, we call it simple event. Correct? The same example. You flip a coin once. Correct? You get head or you get tail. We call it what? This one, a simple event. Correct? To go this way, I'll explain it later in an example for you, that what will be your procedure. Your procedure will be flip a coin. The event, what is your simple event? Having head, whatever your goal is, having head or tail. Correct? After we learn this, the next vocabulary is sample space. Correct? What is sample space? All simple events or simple events, or you can say this way, all possible outcomes. All possible outcomes. We call it what? Sample space. Now, let me explain it in an example. For example, you are flipping a coin 3 times. Correct? In this example, I will explain everything to you. I will show what is procedure, what is simple event, what is sample space. Correct? Flipping a coin 3 times. Correct? And your goal is to have 1 head and 2 tails. One head, 2 tails. In this example, the procedure, if someone asks you what is the procedure in this example, your procedure is flipping a coin 3 times. That's your procedure. I'll change the color here. Procedure, flipping a coin 3 times. Correct? What is simple event? In this example, what is simple event? Having 1 head, 2 tails is your simple event. Correct? 1 head, 2 tails is your simple event. What is sample space? Sample space. Sample space means all possible outcomes. Let me show you. When you flip 3 times a coin, it's possible to get head, head, and again head. Flip 1 time, it comes head. Flip again, again head. Flip again, again head. It's possible. Or you flip a coin, you can take tail, tail, tail 3 times. These 2 is not only the outcome of this event. There are other possibilities also, right? Look, if I start with H first, I can have H, 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 or I can get head, head, then tail. I can have head, tail, tail. I can have head, tail, head. Correct? These are all possibles starting with H. Same way, I can have tail, tail, head. Correct? I can have tail, head, head, or tail, head, tail. These are all possible outcomes, all combinations. Correct? If I use this sign around, if I put them, all of them like this in a braces, starting from here to here, all outcomes, it's all outcomes. Correct? This is your sample space. All possible outcomes, we call it what? Sample space. Please, please focus on this lecture and get to know what is procedure in an example when you're dealing with an example, what is your simple event, what is your sample space. Correct? You see, in this example, if I ask you how many ways you can have one tail, two head, how many ways you can have one tail, two head, correct? How many ways? Look at here in my sample space. One tail, two head, one way. One tail, two head, two ways. One tail, two head, three ways. You can get one tail, two head in three different ways. Correct? Or if I ask you how many ways you can have three heads. Correct? How many ways we can have three heads? Only one way here. H, H, H. Correct? Only one way. Correct? Or how many ways you can have three tails? Of course, one way. Correct? You can have only in one way three tails. Correct? Your sample space explains a lot of things to you. Different ways to accomplish an event. Correct? Now I can write the definition for probability. What is probability? The likelihood of an event occurring. We call it probability. For example, what is the probability to have rain tomorrow? Correct? This is the likelihood of happening an event tomorrow. Correct? Which is rain. Is it raining tomorrow? What's the probability? 50%, 20%, 40%, 30%? We call that probability, the likelihood of happening or occurring an event. We call it what? Probability. Some notation for probability. We denote probability with P. P means probability. We denote event with capital letters. For example, event A. For example, event B. Event C. Correct? Usually we name our events with uppercase letters, correct? With ABC. Now, probability, I will write just probability of an event. How to denote that? P of A. Probability of event A. P of A. Probability of event B. Probability of event C. And so on. Correct? What does it mean? P of A, probability, or let me put the probability of event A, correct? Event A occurring. Same for others. The probability of event B occurring. Correct? That's the meaning of this notation, P of A or P of B or P of C. Now, we know what is probability, we know what is event, we know what is simple event, we know what is sample space. We learn all these vocabularies. Let's talk about types of probabilities. There are three types. There are three types of probability. Correct? The first one, we call it observed probability. What is observed probability? The probability that's estimated based on observation, correct? Based on observation. You observe something, you collect your data, then you find the probability of it. This kind of probability, we call it observed probability. Correct? The example that I did, if you flip a coin, like, let's say 50 times, you are flipping a coin 50 times. Every time that you flip, you observe what's happening in that event and you make a note of it, or you collect data. And at the end, after 50 times, you will say, okay, right now I'll find the probability of having hit in a 50 times. What was that probability? How many times I had hit when I flipped the coin 50 times? Hopefully it's clear for you. It's based on observation, correct? And the formula to calculate that probability, P of A equals, in the top, in the numerator, you have number of times A did occur. Or even we don't need a did here. You can say number of times A occurred, because occurred means did occur, right? Divide by number of times procedure repeated or was repeated, right? Procedure was repeated. That will be the formula to calculate an observed probability. I will do a lot of examples today. I will do a lot, I'll promise. But right now, this is the formula. Correct? Type 2 of the probabilities, we call it classical. Classical probability. What is classical probability? Probability based on the chance of an event occurring. Correct? The probability based on the chance of an event occurring. But a little bit of note here, I'll put in red color. Each simple event, each simple event must have, even I'll underline must have an equal chance of occurring. That's the condition. Look, the good example is flipping a coin. When you flip a coin, which is a simple event, right? Having head is a simple event. And the chance is 1/2. Agree? Let me write down here for you. When you flip a coin, the chance of having a head is 1/2, 1 out of 2, because your coin has 2 sides, head and tail. And also the chance of having a head is 1/2. It's based on chance. When you flip a coin only once, it's based on chance what you get. You get a head or you get a tail, correct? And the chance for both simple events, your simple event is having a head, or another simple event having a tail. The chance for them is what? Half half, equal. One half, one half. Correct? This type of probability, we call it classical probability. Correct? And now, how to calculate a classical probability? We put a formula for it. Again, P of A equals, it's a little bit different, than the wording is different when I'm writing here. Number of ways A should or could, I use should because later I'll explain the word should for you, occurring, divide by number of simple events occurring. That will be the formula for the classical probability. Correct? Now, what are the differences between classical and observed probability? Again, I'll use red color here. These are really important. Star number 1. In classical probability, if I talk about classical, we have what should happen. If it's classical probability, what should happen? Look, flipping a coin. You have two options, head or tail. It's what should happen, right? And observed, we have what did happen. That's why I was trying to put that here for you in the formula. Then I said, okay, number of times A occurred, it means did, right? That's the difference here. What did happen? That is the difference between classical and observed. If I write in a better nice way, let me put here for you. This one is classical and this one is observed. What did happen? What should happen? Correct? Now, the last type of probability, type 3, we call it subjective. Subjective probability. What is subjective probability? Subjective probability means educated guess. Correct? Educated guess, we call it subjective probability. How to explain it to you? For example, you're going to a doctor, you're a little bit a little bit sick, and you tell the doctor, doctor, what are my chances? Or what is my chances? The doctor tells you 80%. It means you're good, you can make it, no problem, you will not die. You can make it, it's 80%, really a high chance, correct? It's educated guess. He didn't observe anything, but it's educated guess, correct? Or if I tell you, right now I'm going out of my office and I go to my car and I see a rock, just a big rock hit my car from the sky. From somewhere it came and hit in my car. If someone asks you what's the probability, well, what is the probability? You can say maybe 1%. Maybe it's happening, something comes from the sky. Maybe 10, maybe 50. You can say anything. It's a kind of educated guess. Correct? It's not based on observation. It's not based on chance. It's educated guess. Correct? Now, let's start with some examples, do some good examples to practice with two formulas that I put for you for the probability, correct? Example number 1. The probability of selecting a heart I mean this, a heart from a deck of cards. From a deck of cards. We know in a deck of playing cards, we have 52 cards. There are two colors, red and black. All of you, you know this much. One type of them is heart. The other one is a spade. The other one is diamond, right? There are 4 types there. They're asking you in this example, what is the probability of selecting a heart from a deck of cards? You have a deck of cards, you just draw one card out of it. What will be the probability that that card is a heart? We have 13 heart in a deck of cards. We have 13 spade in a deck of cards. We have 13 diamond and we have 13 of this guy. Two colors, red and this one is red. This is black and this is also black. Correct? The total of what? 52 cards. They are numbered start in each 13. We have 2, 3, 4, 5. I'm writing this for those of you that you never seen playing cards, but I'm sure everyone already saw what is playing cards, right? 5, 6, 7, 8, 9, and 10. And you have Jack, you have Queen, you have King, and you have Ace. Correct? Which total is 13. Now, in this problem, they're asking you, what is the probability of selecting heart or a heart from a deck of cards? First, the first question that I will ask, which type of probability is this example? Correct? The type, you just randomly select a card from a deck of cards. It's based on chance, correct? And you see the chance for all of them is equal. 13, 13, 13 out of 52. 13 out of 52, 13 out of 52, 13 over 52, 13 over 52. The chances are equal. Then this example is a classical probability. Now, how to calculate? P of having a heart equals how many hearts we have in a deck of cards? 13. Correct? You see the formula for classical? Number of ways A should occurring. How many ways? 13 ways, because you have 13 of them. Correct? Divide by number of simple events, which is what? 52. Correct? If you reduce it, it gives you 1/4, or in decimal, it will be 0.25. Correct? Which means if you multiply it with 100, 25%. When you draw a card from a deck of cards, the chance that that card is a heart is 25%. That's the probability of it. Clear? Hopefully, it should be clear for you, this example. Example number 2. Flip a coin 100 times. And you get 64 tails. What is the probability of having tails? Correct? What is the probability? The probability of tail. P of t, probability of having tail. How many tails you get when you flip a coin 100 times? You're sitting in a home and I give you such a crazy homework. I'll tell you, hey, your homework tonight is to flip a coin 5,000 times and record how many tails you will get. Correct? Everyone in your house will look to you and say, what happened to this guy? Why he's flipping a coin all the time? I will not give you such a homework, don't worry. But here, you flip a coin 100 times, correct? 100 times, and you get 64 tails. What is the probability of tail to calculate? It means 64 out of what? 100, which means 0.64. It means 64%. You see here 64%? 64%. Which kind of probability this example is? Because we are flipping the coin 100 times and each time we record what's happening, we call this example observed probability. It's an observed probability example. Example 3. Python, I think he's a football player, I think, completed 385 passes. Oh, sorry, 385 out of 5 out of his first 528 passes. Correct? Find the probability that Python will complete a pass. Correct? The notation P of what we are looking after, completing a pass. P of completing a pass. The probability of P of completing a pass equals how much he completed out of the first 528? 385. Correct? And if I divide this number by this, which is 528, it gives me a decimal 0.729. Correct? Or you can say 72.9%. And if I ask you, definitely I will ask these during the test and homework. Which kind of probability is this? I think all of you know right now that this is observed. Someone observed that what he is doing, right? He recorded this 385 out of 528. Correct? They're recording this. Then this probability is an observed probability. Correct? Example number 4. You see, I did a lot of examples for you. In a deck of cards, find the probability, find the probability randomly selecting. You see the word randomly comes again. We explained it in chapter 1. Randomly selecting a, let's say, 4. You are looking actually here for P of 4, probability of having 4. When you draw a card randomly, you select a card randomly from a deck of cards, what will be the probability to have 4? How many 4s we should have in a deck of cards? You see, in each type you have 1 4. You see here, in each type of them I have 1 4. Then I have 1 4 here, 1 4 here, 1 4 here, 1 4 here. How many 4s? We have 4 4s in a deck of cards, correct? Then this probability I can write 4. What is the total of cards? 52. 4 divided by 52, which gives you 1 over 13 if you simplify. And if you change to decimal, it gives you 0.076, which means almost what? 7.6%? 7.6%. If you multiply it with 100. Which type of probability is this? It's classical. It's a classical probability. Correct? Two more examples, then I'll stop the lecture. Which example? 5, 4. I lost the number. Example, I think 5. Find probability. Find the probability that a bird poop. This example is interesting. On your car today. You go out and you see a bird is already pooped on your car. What's that probability? There is nothing to record. There is no classical way, equal chance. There's no equal chance that one day poop or not poop, correct? It's not classical. This example is subjective. The answer can be different. You can say, maybe the probability is 1%. Someone say, oh, maybe the probability is 5%. For me, it's always 50%. Every time I see my car, I have to go and wash it again, correct? It's changing from person to person, correct? That's why it's subjective. Last example. Example number 6. Find probability. Find probability that if a couple has 3 kids, 2 will be boy. Two of them is boys. For this, I have to put this for you because we know in reality the chance of having a boy and girl is not equal. Actually, the boys, I think the chance for boy is more, if I'm not mistaken. It's 49 and 51, something like this. You may know better than me because you studied biology. But in this example, assume equal or assuming equal chance of boy girl, correct? You're assuming that the chance of having a boy and girl is equal. It means 50-50. In this example, let's repeat everything once again because this is the last example. What is procedure? What the couple wants? Having 3 kids, correct? That's your procedure. Procedure, having 3 children or kids. What is the event in this example? What is their goal? To have what? Two boys, correct? If they want three kids and they want to have two boys, of course, definitely the other one will be a girl, correct? Then the event is two boys, one girl. Now I will ask you this, and definitely you need to find this. What is sample space? It means all the possibilities, all the outcomes, possible outcomes. It's similar to the first example that we flipped the coin 3 times. You can have boy, 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 or they can have girl, 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 one possibility. Starting with B, boy, boy, BBG, correct? Then B, G, G, then B, G, P. Starting with G, 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 B, G, B, B, and G, B, G. You may say, hey, there are no difference between GGB or BGG. They are the same, but believe me, in real life, there is a difference. Who comes first, correct? For some families, maybe. It's a different structure in a family, correct? Now, these are all possible outcomes. To calculate your probability of two boys, one girl, is two boys, one girl. How many ways? Look how many ways you can have two boys, one girl. We already explained how to find how many ways. Here, two boys, one girl. Here, two boys, one girl. And here, two boys, one girl. How many ways? 3 ways. It means 3 over all possible simple events. All possible, it means divide by sample space. How many of them? 1, 2, 3, 4, 5, 6, 7, 8. It means 3 over 8. Correct? And if you divide, you will end up with 0.375, which is what? 37.5%. The chance of having two boys, one girl, assuming that the chance of having boys and girls is 50-50, is 37.5%. Correct? A little bit of note for you, then I'll stop. Note. You know, the notes are always important, correct? Star number 1, or a star. Probabilities are always between 0 and 1. Always your probabilities are between 0 and 1. 1 means here 100%. 0% and 100. Your probability is between 0% and 100%. Of course. It makes sense, right? It's always between 0 and 1. Now, if we know this, if a probability becomes 0, what is 0 probability? What does it mean? It means impossible, right? Something impossible. We call the 0 probability impossible. probability of 1 means 100%, right? It means you are certain. This is impossible event, even you can put event, certain event. Correct? Still, we have to discuss 4.2. There are other parts in 4.2 that I will discuss. We will discuss the complement, probabilities or complement events, and slowly we will go towards addition rule. We are done actually with section section 4.2. I'll stop the lecture here and see you all in section 4.3.